in order to make the world a better one and more thriving place, and to utilize energy for a better world. Powered by unwavering passion and technological capacity, relentlessly strive to make R&D efforts. Kogas Research Institute. Korea Gas Corporation has become the country's first entity to blaze into an overseas shale gas development project by signing a contract for the development of 3 gas fields in Canada in 2010. The Horn River Basin, where the fields are situated, is located in northeastern British Columbia and southern parts of the Northwest Territories. The basin covers an area of about 13,000 kilometers squared of land. The Horn River Basin is known as one of the prolific shale gas fields in Canada, with 2,300 meters to 2,600 meters deep and 120 meters to 170 meters thick shale gas strata. The original gas in place volume is estimated to about 500 TCF. In particular, Kiwigana Field, one of the contracted fields, contains 5.1 TCF of the original gas in place volume on a total area of 100 square kilometer basis. The gas produced from the area has emerged as one of major energy sources ever since the very first production was made in May 2013. Our organization has also spearheaded a 4-year-long feasibility study since December in 2013 with 8 major Korean institutes to improve the fracturing efficiency of shale gas formation. Korea Gas Corporation is on track to maximize efficiency in the performance each phase by utilizing advanced equipment and technologies in order to enhance productivity in the shale gas production. We are focused on this study to secure in-house analytical capacity to the shale gas technology and standardized evaluation techniques on the gas exploitation and production. The purpose of such activities is to make ourselves become a leader in resource developments. Shale gas is natural gas that is trapped within the source rock, which contains far lower porosity and permeability than conventional reservoirs such as limestone or sandstone, where natural gas is produced from. In order to produce the shale gas, the hydraulic fracturing technique is applied to reach the gas shale through the horizontal drilling, unlike the traditional ways to produce, since fluidity is fairly low in the shale formation. Then, the process involves the high-pressure injection of fracking fluid, primarily containing water, sands, and chemicals in mixture. In efforts to analyze the shale gas formation, a study on seismic interpretation and geological field survey should be carried out first to clarify stratigraphy, sedimentology, and structural elements. This geological analysis helps understand a thickness and extension of a targeted layer. Through core analysis on the targeted layer, each facies is categorized into different groups: CT, SEM, XRD, rock eval analysis are applied to make geochemical and mineralogical classifications. Therefore, more detailed and segmented classifications can be realized than that for the traditional gas developments. At first, structure model is built based on the seismic data interpretation results. Reservoir facies and properties are analyzed according to the depth using core and well log data. Reservoir property model is projected into a 3D model using integration of the well log property results and seismic data inversion results. Finally, Sweet spots and drilling trajectories are selected considering the influential factors for productivity, such as reservoir rock property and frackability. To develop the sweet spot which is derived from the prior analysis, actual drilling activities are kicked in. In general, shale gas is developed by the horizontal drilling. This process involves drilling vertically until reaching a kickoff point, and then increasing a well-bore angle until it gets the horizontal angle. Once the drilling job completes, casings are injected to keep the wellbore stable with cements cast around. A technology to control and adjust a drilling trajectory precisely enough to locate a horizontal well within a targeted layer is prerequisite, since the shale gas strata has a feature of spreading thinly and widely over an area. The hydraulic fracturing is a technique to secure a path for gas to flow through a drilled wellbore. The process involves injecting a high-pressurized fluid into the hole to hydraulically fracture the reservoir and fill gap with sands for production. In case of a long horizontal well, multi-stage fracturing is applied. Microseismic monitoring system is designed to detect any changes to a layer caused by the hydraulic fracturing in an effort to see how the induced cracks are propagated in the rock. Such system would help identify feasibility of the hydraulic fracturing and establish a future development plan in the field. Research Institute of Korea Gas Corporation attempts to make the hydraulic fracturing work more efficiently by modeling it and examining it with the field-measured microseismic data. This model makes it possible to evaluate hydraulic fracture design parameters in terms of gas productivity. The prop end holds up the fractures open during production, and it ensures that gas can be produced through the fractured layer. Once gas and water comes out of the reservoir, pore pressure decreases and load pressure increases in the reservoir so that a fracture width gets smaller. In order to predict how much gas can be produced from shale reservoir, the dynamic model can be constructed regarding reservoir and fluid properties, relative permeability, capillary pressure, diffusion from matrix to fracture. Next, for the sake of evaluating productivity of the reservoir, it is necessary to integrate structure, facies, and fracture models from G&G department and dynamic model from reservoir engineering department. The constructed evaluation model can be used to predict how much gas could be produced in the future and make a development plan for infill drilling. This produced gas from shale reservoirs is transported to the surface facilities and refined. Then, it is delivered from the LNG terminal to the market through pipeline in form of liquefied gas. Kogas Research Institute is committed to explore a hidden value to turn it into a source of happiness and comfort. Many players from home and abroad support the shale gas development project in every way as they pay keen attention to our technology and passion. Kogas Research Institute starts today with full of energy as always to make the world a better one that everyone seeks. Next Energy. with Kogas. Kogas Research Institute.